What's up, guys? Welcome back to the channel. Today in this video we'll be doing the application of de Moivre's theorem. Now we have this problem here that requires us to apply this theorem here. So before we solve this problem, how about you pause this video, try to solve this problem, and let's see if your answer is going to be the same answer as the one that we're going to get at the end of this video. Now, before I start solving this, I just like to say thank you very much, guys, for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, guys, subscribe to the channel because I've made lots and lots of videos solving problems similar to this one and also solving previous question papers as well. All right, let's look at this problem here, guys. As you can see, this problem here, we are given this in a complex numbers, but these are actually in a polar form. So we can only apply the de Moivre's theorem only in a polar form. Now, we just need to rewrite these two here, 3 cis 6 to the power of 3, and then 2 cis negative 50 degrees to the power of 2, because this it's also a polar form, but it's in a different notation where C stands for cos, I stand for imaginary, and S stand for sine. We need to write it in a form whereby we can easily simplify. So we're gonna rewrite this as it is because this one is in a form where we can simplify, right? Multiply. So let us not forget that this is going to be 3 polar 60 degrees to the power of 3 divided by, right? This is going to be 2 polar negative 50 degrees to the power of 2. Now, if you continue like this here, it's time for us to apply the de Moivre's theorem. Now, on this one here, it doesn't have any exponent, so we're just going to rewrite it as it is. Right. So let's apply the de Moivre on this one here. Now we have the exponent of 3, so the modulus, which is 3 there, is going to have the power of 3. And then the argument, which is 60, is going to be multiplied by 3. There we go. Basically, this is how you apply the de Moivre. Now let's do the denominator. Now, as we can see, the 2, which is the modulus, is the power of 2. And then the argument, which is going to be negative 50, is going to be multiplied by 2. Right. Just in case you don't know how to apply the de Moivre's theorem, I've made a video introducing the de Moivre's theorem. You can go to the description, click on that video, and watch the de Moivre's theorem introduction. And also that video will pop up on the top right of this video that you're watching there. Right, guys, let's continue. If you continue here, this one, we continue dropping it as it is, 4, and the angle is 45 degrees. Multiply. Now, we know that 3 to the power of 3, this is going to give us 27. Right. Then the angle, which we know that is going to be 3 multiplied by 60, is going to give us 180 degrees. Divide by. There we go. Now, we know that 2 to the power of 2, this is going to give us 4, the modulus. And then when it comes to the angle, it is going to give us negative 100 degrees. All right, so the modulus is going to be 4 and the argument is going to be negative 100 degrees. Right, so we're going to continue here. Now, when you look at the numerator there, we have two complex numbers in a polar form multiplying each other. So here's what you need to know. When the complex numbers in a polar form multiply each other, the modulus, which is 4 on the numerator, is going to multiply with the modulus, which is going to be 27 there. Right. But then what about the arguments? The arguments, they're going to add. So we have 45 plus 180 degrees. Right. So all this is divided by the denominator. So I prefer us to first deal with the numerator. So we're going to have negative 100 degrees. So the next step here, we're just going to multiply the modulus, which is 4 multiplied by 27, which is going to give us 108. There we go. As for the argument on the numerator, they're going to add each other. 45 plus 180, this is going to give us 225 degrees. Divide by 4. Angle is going to be negative 100 degrees. All right, so when it's like this, now we can do the division. But before we do the division, just in case you don't know how the multiplication of the complex numbers in a polar form work, I've made a video explaining this multiplication of polar complex numbers. So you can go to the description, click on that video, and also that video pop up on the top right of this video. Now let's do the division of complex numbers in a polar form. Now when you divide complex numbers in a polar form, the modulus, they're gonna divide each other. So it's gonna be 108 divided by 4, and then when it comes to the argument, they're going to subtract. But since our 100, it's negative, when it goes to the top there, it's going to become positive. So this is going to be 225 plus 100 degrees, right? The modulus here, they're going to give us 27. And then as for the arguments, they're going to give us 325 degrees. Basically, this is how you solve this problem here. So this problem contains the Moivre's theorem and also the multiplication and the division of the complex numbers in a polar form. Just in case, again, you don't know how to divide the complex numbers in a polar form, I've made a video explaining the division of complex numbers in a polar form. All right, guys, if it so happened that you didn't understand, go to the point whereby you got lost, rewatch from that point. And also, if that doesn't help, you can leave a comment in the comment section and I will try to answer you to my level best. If you manage to watch this to the end and you haven't subscribed to the channel, subscribe to the channel. By the way, thank you very much, guys, for watching. Till next time, cheers.